Imagine a world where machines do the work of thousands, where a single robotic arm welds 4,000 joints per hour, without rest, without error, without complaint. Right now, over 4 million industrial robots are actively working across the globe. But how did we get here? The answer will surprise you. Because this story doesn't begin on a factory floor, it begins in an ancient temple. Travel back 2,000 years, to the city of Alexandria. A mathematician named Hero is standing inside a temple. And he's about to do something no one has ever done before. He builds a mechanism, a system of pipes, pressure, and heat, that opens the temple doors automatically. No human touch required. This was not a toy. This was not a trick. This was the first recorded automated mechanism in human history. But Hero didn't stop there. He designed machines that played music on their own. Water systems that balanced themselves. Even a primitive steam engine, 2,000 years before the Industrial Revolution. Think about that for a moment. If Hero's work hadn't been lost to history, the world as we know it might have arrived 1,000 years earlier. Fast forward to 1495, Florence, Italy. Leonardo da Vinci is sitting in his workshop, filling pages with sketches no one can quite understand. For centuries, one particular drawing puzzled historians. It showed a figure, armored, jointed, mechanical. Modern engineers finally decoded it. They built a physical model based on Da Vinci's exact specifications. It worked. Da Vinci had designed a functioning robot 500 years ago, but his notebooks were never published. His ideas were never shared. And so, once again, humanity had to start over. 1784, Britain. James Watt perfects the steam engine. And the world splits in two, before and after. Factories rise from the earth, machines replace muscle. And in 1801, a French inventor named Joseph-Marie Jacquard introduces something that nobody recognizes for what it truly is. A loom, controlled by punch cards, different pattern, change the card. The machine figures out the rest. Today, we have a name for this. We call it programming. Charles Babbage saw Jacquard's loom and had a vision. That vision became the blueprint for the modern computer. And that computer now runs the robots that are reshaping our world. Then came Henry Ford, 1913, Detroit, the moving assembly line. Every worker, one task, one motion, repeated endlessly. Production time collapsed, costs plummeted. And a question rose from the factory floor: why should a human do this at all? World War II, the most destructive conflict in human history, and the greatest technological leap our civilization has ever made. The Allies needed to break Nazi Germany's encrypted communications. Codes so complex, hundreds of mathematicians couldn't crack them in a lifetime. Alan Turing thought differently. Build a machine, he said. Let the machine do what the human mind cannot. He built the bomb, an electromechanical device that could analyze thousands of combinations. In minutes, it changed the course of the war. And from that breakthrough, Turing laid the theoretical foundation for the modern computer. In 1945, ENIAC came online. An entire room filled with 18,000 vacuum tubes, capable of 5,000 calculations per second. By today's standards, laughably slow. By 1945 standards, an absolute miracle. The age of automation had officially begun. 1961. A factory floor in New Jersey. General Motors installs something new. Something that has never existed before in an industrial setting. Its name is Unimate. Unimate is a robotic arm, built by George Devol and Joseph Engelberger. Its job is to pick up scorching hot metal castings from a die casting machine and stack them perfectly every time. This was dangerous work, exhausting work, work no one wanted to do. Factory workers were skeptical. Some were afraid, some were angry, but Unimate worked. It worked efficiently, it worked flawlessly. And General Motors ordered more. Engelberger would later be called the father of robotics. And Unimate would become the spark that ignited an entire industry. The 1970s, Japan is rebuilding from the ashes of World War II, and they make a decision that will reshape global manufacturing forever. Robotics becomes national strategy. Toyota, Honda, Mitsubishi, they don't just buy robots. They build them. Fanuc, Yaskawa, Kawasaki, names that today dominate the global robotics market, all born in this era, all born in Japan. The Scara robot emerges, designed for precision assembly. Capable of movements no human hand could replicate consistently. Every electronic device you've ever owned was likely touched by a Scara arm. In Europe, Kuka and Up rise to power. In America, the automotive industry pushes automation further than ever before. A global race has begun, and the machines are winning. 1997, NASA's Pathfinder spacecraft lands on Mars, and a small rover named Sojourner rolls out onto the red surface. Millions of kilometers from Earth, no human guidance in real time, making its own decisions, navigating its own path. This was a quiet moment, but a revolutionary one. A machine was thinking for itself. Around the same time, Honda unveils Asimo, a humanoid robot that walks on two legs, climbs stairs, dances, waves. The crowd is amazed and a little unsettled. Then machine learning arrives, and everything changes. Again, robots are no longer just programmed. They learn, they fail, they analyze, they improve, they try again. Boston Dynamics releases videos of robots running, backflipping, navigating obstacle courses. The internet goes viral. Half the comments are filled with wonder, the other half with fear, because for the first time, people realize these machines are no longer just tools. Right now, Amazon operates over 750,000 robots across its fulfillment centers. The Da Vinci surgical system performs operations with a precision no human hand can match. Millimeter accuracy, zero tremor. Autonomous tractors plow fields guided by GPS. Drones monitor crop health in real time. Farmers manage thousands of acres from a tablet. Self-driving vehicles have logged billions of test kilometers worldwide. Waymo, Tesla, Cruise, all racing toward the same destination. The global industrial robotics market surpassed $80 billion in 2024. By 2030, it's projected to reach $165 billion. This is not a trend. This is a transformation. 2,000 years ago, Hero opened a temple door with a machine. Today, a robot is collecting rock samples on Mars, and between those two moments, humanity did what it has always done. It faced a problem, it refused to accept limitation, and it built something that had never existed before. Artificial intelligence and robotics are now merging. Where that leads, no one knows with certainty. But one thing is clear, the direction of this technology will be decided by human beings, by engineers, by designers, by thinkers, by people like you. If this video sparked something in you, subscribe for more stories from the frontiers of human ingenuity. The next chapter is already being written.